This is do the examples below require a linear or exponential growth model? State whether each example is linear or exponential and write an explicit formula for the sequence that models the growth for each case. Include a description of the variables you use. Okay, so jump in here if you know the answer to one of these. It says a savings account accumulates no interest but receives a deposit of $825 per month. So first of all, is that going to be linear or exponential? Linear, yes. So if it's going to be linear, what is the formula going to look like? Let's go with alpha of t is equal to what? All that's happening is $825 is getting put into the bank account each month, right? So we can just say 825 times however many months they are, right? So if it's the 5th month, you're just going to say 5 times 825, and that's going to tell you how much money is in the account after. So T is the months, okay? And alpha of T would then be what? The amount, the account. Oh, I can't spell account. Account. Well, I still can't spell account. Sorry. Account total. I still can't spell total. Wow. Okay. Account total after T months. Okay. Everybody understand where we get that? Anybody not understand number one? That one's pretty easy. It's linear, right? All right. Let's go with number 2 now. The value of a house increases by 1.5% per year. Is that going to be linear or exponential? This is going to be exponential. And the reason why is because the value is going to increase depending on however much money is in the, how much the house was worth the year before. Okay. In the previous problem, it didn't matter how much was in the bank account the previous month. It was just going to be $825 going into it, no matter how much was in it the month before. Here, it depends on how much the house is worth the previous year, because it's going to go up by 1.5% of that amount. So we would call this formula to be alpha of t is equal to what? Well, we don't know the beginning value of the house, right? But we got to include that. So we'll call that B of, nope, not T. I'm going to call that 1.015 T. B is the beginning value. T is the years, right? And of course, alpha T is going to be the amount after that year. Okay? Everybody good with that? Notice that you have to have a beginning amount for exponential growths or decays. Okay, and that beginning, we don't know what it is, but we're going to account for it would be there. Okay? All right. Number 3 says, every year the alligator population is 9/7 of the previous year population. Linear or exponential? Yeah, this one's going to be exponential. Okay. Jaden, T does not equal months in number 2, T equals years. In number 1, T equaled months. Oh, you mean minus. Sorry, no, that's going to be equals. That's what you're getting at. Sorry. Yeah, T equals months in number 1, not T minus months. Okay. Yeah. Who is that? Kat said exponential? Okay. Yeah, this one's going to be exponential too because it depends on the previous year's population, right? So we're going to have f of t is equal to, now, we don't know what the alligator population is, so you should be able to figure this out. It's going to be, we'll call it A for alligators, and it's going to be 9/7, and then to the t power. Okay, A is equal to the alligator population, and T is equal to the years. And then, of course, F of T is going to equal the amount for that year, the amount of the population after that year. Everybody got that? Got a little bit better of an understanding for exponential growth and explicit formulas here. Now, number 4 says the temperature increases by 2 degrees every 30 minutes from 8 a.m. to 3:30 p.m. each day for the month of July. Is this going to be linear or exponential? Linear. Good job, Jordan. Because does it matter what the degrees was at 7:30? It does in the fact that you got to come up with how much it is at 8, but it's only going to grow by 2 degrees no matter what the degree was at 7:30, right? How much it's growing doesn't matter based on the previous 30 minutes. It's going to grow by 2 no matter what. Okay. So here we would say, let's call it the temperature of T is equal to what? How would you write this formula? Okay. Let's do this. We're going to start with B, right? That's the beginning temperature. And then we're going to have to say to what? This one's going to take a little bit of thinking here, okay? We're going to say 2 times T, and T is half hours. Okay? So at 9 a.m., that would be 2 times 2, because that's 2 half hours, right? Past 8 a.m. And then that would be plus our beginning temperature, which we don't know. Okay? So B is again the beginning temp. And T is going to equal the half hours. Okay. Like I said, for example, 9 a.m. would be 2 half hours. So 2 times 2 is 4. It would have increased by 4 degrees by 9 p.m. By 9 a.m. And that makes sense because it's going up by 2 every half hour. Okay? Everybody understand that? Anybody got questions? All right, let's keep going. Number 5. Number 5 says every 240 minutes, 1/3 of the rodent population dies. Okay. Anybody want to tell if that's linear or exponential? Good. Faith, Jaden, and somebody else. I don't know who said exponential. All said it was exponential. Good. Okay. Now, this is the part y'all struggle with, right? It's writing the formulas. Okay. So, anybody want to take a stab at this? We'll call it R of T for rodents, the rodent population. This one's fairly easy. We're going to say that it's P, which is the population of the rodents, times what? I was hoping somebody was going to say that. And Faith typed it, and Michael also said it. That is incorrect. Kat says, how is that incorrect? Nope, not 240. We're talking about the population. We're not talking about how many died. 1/3 died, so how much of the population is left? 2/3. Good. So 2/3. Now, Jaden, you said 240. T is going to be representative of our 240. I like how you are now calculating somehow every aspect of the question. But T is what? What's 240 minutes? Is that 4 hours? Yeah. So T is going to equal every 4 hours or 240 minutes. Okay. So if it's 8 hours, then T would be 2. 12 hours would be 3. Okay. Okay. Everybody got that?